Hey guys, welcome back. This is part 2 of our discussion on completing the square. I ended up with number 6 in the last video being a total nightmare, and I'm going to just erase from my memory, pretend it didn't exist because I'm not a big fan of it. So what I'm going to do for the second half of the video is I'm going to go over examples 7 and 9, which is the bottom left side of your notes, and I'll leave 8 and 10 to do for you guys to do to demonstrate to me that you understand these notes. So let me continue on. Number 7, we have our quadratic equation. However, we have a constant on the left and on the right side. So I have to get rid of this constant that's on the left, and I'll do that by adding 21 to both sides. That way it'll remove it from the left side. Now I have x squared plus 16x equals negative 5 plus 21 gives me a positive 16. So now I need to check, is my x squared have a coefficient of 1? And yes, there's only one x squared, so I can skip step 2 and go on to step 3. Step 3 says take my b value, cut in half, and square it. My b value is 16. 16 cut in half is 8. 8 squared gives me a 64. So what I'm going to do is I'm going to add 64 to the left side of my equation and to the right side of my equation, 64, to make it a perfect square. So now a perfect square trinomial, to be specific. So x squared plus 16x plus 64 now equals 16 plus 64, which is 80. My bad. Yeah, that's right. Now let me factor the left side. I need two numbers, preferably the same number, that'll multiply to give me 64, but add to give me a 16. And those numbers would be positive 8. So what I essentially have is x plus 8 times itself equaling 80. So now to solve for x, to get the x plus 8 by themselves, I have to undo the squaring, and I do that with square rooting. So now I have x plus 8 equals the square root of 80. Let me break down the square root of 80 because it's not a perfect square. The square root of 80 can be derived by taking the square root of 16 times the square root of 5. The square root of 16 is just 4, positive 4 and negative 4. The square root of 5, however, does not get any smaller. So here is my left side, I'm at the right side of my equation now. So now I have to say, to get x by itself, I'm going to have to subtract 8, minus 8 here, minus 8 here, and my final answer, the way I'm going to write this answer is x equals, because none of these cancel out, a negative 8 plus or minus 4 square roots of 5. I can leave it just like this because I have all these irrational and decimal numbers. So this will be an appropriate way to display my answers. I don't have to go on because I'm not going to get any whole number answers I can write down very simply. So I can leave it like this, and that'll be just fine and mathematically acceptable. So do number 8, it follows the same exact pattern. Now going on to number 9, our final example for these notes. Once again, I have my quadratic formula, but my constant, 43, is on the left side. I need to move it to the right side, so I'll subtract 43 from both sides of my equation. When I do that, I get x squared plus 12x equals a negative 43. Now I need to do the b divided by 2, and then square the routine. My b value is 12. Divided by 2 is 6. 6 squared, or 6 times 6, is 36. So 36 will be the amount that I add to both sides to get a perfect trinomial. As I do this, I now end up with x squared plus 12x plus 36. Negative 43 plus 36 is negative 7. I did already notice that I had a 1 coefficient, so I didn't have to do step 2, which says to divide everything by a, because it's 3 by 1. So now going on, I need to get the x squared, which is x times x. What two numbers multiply to give me a 36 and add to give me a positive 12? That would be x plus 6 times itself. Now I need to go ahead and undo that squaring, and I'll use square root on the right and on the left. So I have x plus 6 equals square root of negative 7. However, square root of negative 7. It's a negative square root, so it's going to be negative 1 times positive 7. And we know that square root of negative 1 is I. Square root of 7 is just the square root of 7. So I have I times the square root of 7. So to solve my equation, x plus 6 equals, and don't forget, there's a positive and negative version. Positive and negative version of I times the square root of 7. To get x by itself, I subtract 6 from the left and 6 from the right. To get my final form of the answer as x equals negative 6 plus and minus I square roots of 7. So this is why we studied imaginary numbers, because they do pop up in quadratics. Now go ahead and try number 10, for it behaves the same exact way, and show me those answers. I hope this video helped you somewhat with your introduction to perfect squares. Of course, after you watch it, if you have any questions, comments, complaints, I suppose, go ahead and let me know. Feel free to like and subscribe. I am not monetized, so I guess it won't make much of a difference. But it's nice to have subscribers. All right, best of luck, guys.